Hey there, I'm John, and this is Eisel.
Hello there.
Today we're going to get you started with your Metrotom 1. In this getting started, we'll be teaching you how to locate and classify internal part defects with ZEISS Inspect software. Feel free to pause at any point to follow along, and there's also chapter segments if you wish to skip ahead. So of course, when 3D scanning using CT technology, one of the primary advantages that we can see inside of parts to look for internal features and defects. In a previous getting started, we explained how to look inside of parts by manipulating the volume visualization, reducing transparency, and taking slices on the volume. If we focus on internal defects, this is sufficient for a qualitative visual check. But what if we want to proceed in an automated and quantitative way? ZEISS Inspect has you covered. Let's have a look.
First, we want to polygonize our volume. For those not familiar with this term, polygonization is the process of turning your scan data into an STL mesh file. An STL file is simply a point cloud that allows us to create a highly accurate part surface for inspection purposes. This is essentially the digital twin of the part. To do this, we simply right-click the volume in our project, select Polygonize Volume, and click OK. Using the high-quality polygonization settings, we can move forward to get our mesh.
So now that we have our mesh, we can go ahead and move on in the inspection ribbon to volume defects. Under this, you'll find the function volume defects mesh. From this command, we'll just make sure your mesh is selected in the dialog and hit OK. If we double-click the STL, go to display, and reduce the transparency, we're going to immediately see our extracted defects in 3 dimensions. So the volume defects we created are now their own inspection element. To see what's possible from here, click on the element itself, go to the iInspect wheel, and click Checks. Looking at this menu, all inspection options for these defects become clear. We can look at many things here, namely porosity percentage, defect volumes, maximum defect length, or even defect distance to outer surface of the part. Let's go ahead and go for defect volume and click OK. Immediately we see that our defects are color mapped based on their volume. To take a deeper look, we can begin putting labels on each defect to see how large they are.
We can even go one step further and add an Inspection Details tab next to the PIP. We can see our volume defect data tabulated for further insights. Along the way, let's not forget to add report pages so that these results are documented for future use. As I mentioned earlier, the parametric nature of this software allows us to repeat the same inspection on any new parts that we scan in the future with no extra work. Now that we have these visualized in 3D, let's return to our multi-view, which can be accessed in the top right corner here. If we make sure that both our linked volume and volume defect element are active, visible in our Explorer on the left, we will be able to see our defect outlines in the 3 section views and color-coded by volume, just as they were in the single 3D view. If you would like to focus on a particular point, you can set focus point from any of the 4 windows.
Yeah, I really like this set focus point functionality. Thanks, Eisel. So that's it for today. If you experience anything different from what you've seen here, or if you have any issues with your Metrotom 1, please visit handsonmetrology.com. And for more getting started information, please check out our other videos. Thanks for watching, and we'll see you next time.